Let's look at transformations of absolute value functions. So first let's look at translations. And translations is the mathematical word for shifts. And these can be up or down or left and right. So first let's look at the type that are of the form y equals the absolute value of x plus d. This will shift or translate the graph vertically, meaning in the y direction, d units up if d is positive or down if d is negative. So for example, y equals the absolute value of x is our parent function. And if we want to look at y equals the absolute value of x plus 3, we have this graph here in blue. It's easier to look at them on the same coordinate plane. So here we can see the parent function in red, our translated graph in blue, and we can see that our graph is translated up 3 units. Y equals the absolute value of x minus d shifts our graph down d units if d is positive. So for example, y equals the absolute value of x, y equals the absolute value of x minus 5. Here our graph would be shifted down 5 units. Okay, let's look at the other type of translation. So y equals the absolute value of x plus c. So this will shift or translate the graph horizontally, meaning in the x direction, and it will go c units to the left if it is the absolute value of x plus c and c is positive. So for example, y equals the absolute value of x, that's our parent function. Y equals the absolute value of x plus 2 will shift the graph 2 units left. Looking at them on the same coordinate plane, we see our parent function in red, we see our translated graph in blue, and the blue graph is indeed translated 2 units left. Y equals the absolute value of x minus c shifts the graph c units right if c is a positive number. So for example, y equals the absolute value of x would be our parent function, and y equals the absolute value of x minus 1 would shift the graph 1 unit right. So try this. Graph y equals the absolute value of x and y equals the absolute value of x minus 4 on the same graph. What is the transformation? So pause this video while you try to graph these and identify the transformation, and then check your answers here. Here we see on the same coordinate plane the graph of the parent function y equals the absolute value of x in red, and y equals the absolute value of x minus 4 is graphed in blue. And here y equals the absolute value of x is translated 4 units down to create the new graph. Also try this. Graph y equals the absolute value of x and y equals the absolute value of x plus 3 on the same graph. And then again, what is the transformation here? So pause this video while you graph and identify the transformation, and then check your answers here. Here on the same coordinate plane, we see the graph of the parent function, y equals the absolute value of x in red, and y equals the absolute value of x plus 3 is in blue. And here, y equals the absolute value of x is translated 3 units left. Okay, let's look at some reflections, sometimes called flips. So y equals a times the absolute value of x. So right now we're just going to look at whether a is positive or negative. So here a is greater than 0. And then the function will open up. We will have an absolute value function, which is in the shape of a V, opening upward. If a were negative or a is less than 0, the function opens down. So the V opens down. And here we say that the graph is reflected over the x-axis. So for example, we've got y equals 3 times the absolute value of x. Its graph looks like this. It opens up. But y equals negative 3 times the absolute value of x. was graphed here and it opens down. If we look at them on the same coordinate plane, we can see that they are reflections of each other over the x-axis. Okay, so let's look at the other type of reflection. Y equals the absolute value of b times x, where b is greater than 0. That would be like our starting graph, not reflected. And if I had b less than 0, then we would have our graph reflected over the y-axis. So y equals the absolute value of x is our parent function. And if I were graphing y equals the absolute value of negative x, it looks like this in blue. These actually look the same, but that's because the graph in blue is the original graph reflected over the y-axis. But because the axis of symmetry for the absolute value function is the y-axis, it's going to look the same. Okay, let's look at stretches and compressions. So first we'll look at y equals a times the absolute value of x. Here, when a is greater than 1 or a is less than negative 1, then the graph is stretched vertically and looks thinner. If a is between negative 1 and 1, then the graph is compressed vertically and looks wider. For example, y equals the absolute value of x is my parent function. Y equals 3 times the absolute value of x. Here, 3 is greater than 1, so it should be stretched. And when we look at the graph, it looks like it's stretched vertically. So imagine stretching it away from the origin, stretching it, pulling it up. And now it looks taller, thinner, but it's stretched vertically. Y equals 1/3 times the absolute value of x. So here a is between negative 1 and 1. So this is going to be compressed vertically. When we do that, if we're pushing the graph in towards the origin, it looks like it gets wider. Okay, let's look at the other type of stretch and compression. Y equals the absolute value of b times x. So when b is between negative 1 and 1, then the graph is stretched horizontally and looks wider. When b is greater than 1 or b is less than negative 1, then the graph is compressed horizontally and looks thinner. So let's look at some actual graphs. So here we've got first our parent function, y equals the absolute value of x. Let's look at y equals the absolute value of 1/3 x. So because b is between negative 1 and 1, this graph is stretched horizontally. So imagine pulling it away from the y-axis, stretching it, and it looks wider. And then if we look at the graph of y equals the absolute value of 3 times x, here b is greater than 1, 3 is greater than 1. So imagine compressing the graph, pushing the graph towards the y-axis. And it will look like it's stretched and thinner. It will look thinner, but it's compressed horizontally. And it looks like the blue graph. Okay, so here we've got a special form where we have all of our parameters. Y equals a times the absolute value of b, parenthesis, x minus c, close parenthesis, close the absolute value, plus d. And this is sometimes called general form. And sometimes you will see this with the letters A, H, and K. When it's in general form like this, the coordinate, the point formed by C comma D is the coordinate of the vertex. The axis of symmetry has the equation x equals c. And the absolute value of A is the stretch or compress factor. So for example, If we had y equals 3 times the absolute value of x minus 4 plus 2, our vertex is at the point 4, 2. The axis of symmetry, AOS stands for axis of symmetry, has the equation x equals 4, and it's stretched by a factor of 3. If we had y equals 2 times the absolute value of x plus 3 minus 8, the vertex is negative 3, negative 8, and that's because if we look at our general form, it's expecting x minus a number, so we can rewrite ours as y equals 2 times the absolute value of x minus negative 3 minus 8. So our vertex is negative 3, negative 8. Our axis of symmetry has the equation x equals negative 3, and it's stretched by a factor of 2.